Today we're going to study the last kinds of problems that involve inverse trigonometric functions. And you can see here that I have yet another complex trigonometric statement that contains the regular sine function and the inverse tangent function. Unlike problems I've done before, I look over here and there's no numerical ratio. I know that this is an inverse tangent function, therefore this should be a numerical ratio, yet it is not. Can I still work this problem out? The answer is yes, I can. I'm going to say x stands for some positive number here whenever I see it in these problems. And I'm going to use again my right triangle to help me out in this particular problem. I'm going to say this is actually a ratio and this is actually x over 1. Now here's the angle that produced that ratio, and since tangent is opposite over adjacent, I'm labeling my triangle x for the side opposite and 1 for the side adjacent. I am missing the hypotenuse here, and I'm going to label the hypotenuse C. Very often the label we give the hypotenuse when we're talking about the Pythagorean theorem. Now this should give me an angle. An angle produced this ratio x over 1 when I took the tangent of it. Now I want to take the sine of that same angle. To take the sine of that same angle, I need opposite over hypotenuse. Can I put x over c? The answer to that question is no. I've got to keep my statement in terms of x's. That's the only acceptable unknown in this particular problem. So I'm going to find the length of the hypotenuse in terms of x's and 1's. I'm going to again use my Pythagorean theorem, a squared plus b squared is equal to c squared. I'm going to say I don't know c squared, that's what I want to find here. X is the side opposite and 1 is the side adjacent. When I square those sides, I get 1 plus x squared is equal to c squared. Now I'm going to take the square root of both of those sides, and I get the square root of 1 plus x squared is equal to c. Some students would like to tell me that the square root of 1 plus x squared is 1 plus x. That's not true. In order for this to be a perfect square, it would have to have two identical factors. And the polynomial 1 plus x squared does not have two identical factors. In fact, the sum of two perfect squares cannot be factored at all. So I'm going to leave it like this. So now I know that c is really equal to the square root of 1 plus x squared. And now I can take the sine of this angle. The sine of the angle here is opposite over hypotenuse. And I'm going to say that gives me x over the square root of 1 plus x squared. Some students might look at this and say, gee, should I rationalize that answer since there's a radical in the denominator? And frankly, from what I've seen from most textbooks, there really isn't a need to do that. That's a perfectly acceptable answer, and you can see my answer is in terms of all x's and 1's, as we can see here from the labeling of our right triangle. The next problem we're going to try is one involving secant and the inverse sine functions. Again, it's a complex statement because we have both a regular trigonometric function and an inverse trigonometric function. And yet again, I see here, instead of having a numerical ratio for the inverse sine function, I have a fraction that has no numerical value that I know of yet. X obviously stands for some number, but I don't know what that number is. So yet again, I'm going to speculate here, and I'm going to draw my right triangle. I'm going to label this angle omega, and I'm going to say, okay, when I take the sine of this angle, sine is opposite over hypotenuse. Okay, and that's how I got this ratio when I took the sine of this particular angle. So there, that produces the angle theta. Now I want to take the secant of this angle. The secant of angle theta is actually going to be hypotenuse over adjacent, because secant is the reciprocal of cosine. Since cosine is adjacent over hypotenuse, I'm going to use hypotenuse over adjacent. But you can see we're missing the length of our adjacent side here. I'm going to call this side A. A for adjacent. And I'm going to say I'm going to be able to find the measure of this particular side of my right triangle using x's and 1's. Again, using the Pythagorean theorem, a squared plus b squared equals c squared. And here, I don't know the measure of side A. I'm going to say that b is the other leg, it's 1, and c squared is the hypotenuse squared, which is x squared. This gives me a squared plus 1 is equal to x squared. I'm going to get a alone on one side of the theorem, so I get x squared minus 1. Now I'm going to take the square root of both sides, and I get a is equal to the square root of x squared minus 1. Can I take the square root of x squared minus 1? No. This polynomial can be factored, but it doesn't have two identical factors. X squared minus 1 factors into x plus 1 times x minus 1. Since those factors aren't identical, I can't take the square root of x squared minus 1, and I'm going to leave it like it is. So now I can go back up here and say this is the square root of x squared minus 1. And now I'm going to be able to take the secant of that angle. The secant of that angle is hypotenuse over adjacent, x over the square root of x squared minus 1. I'm not going to rationalize this, but I am going to say that this is the final answer I have to this particular problem.